So this is basically our topic is for the research is POS-Augmented Statistical Parsing Framework using Tree-Adjoining Grammar for natural language processing. These are the authors. Our area of work is natural language processing, machine translation, and basically Tree-Adjoining Grammar. So this is the structure of the presentation, background and motivation, introduction, research development environment, our experiment with tree banks, future scope and conclusion. And there's a literature survey also we have done. So we basically our research basically focused on the advancing NLP through the improved parsing technique, multilingual model, adaptable for the NLP systems. These our objective is the innovation through our innovation. We aims to fill our gaps in language resources, enhance the machine translation quality, and provide the powerful tools for NLP research. As a part of our research, we have actually already developed multilingual tag parser, statistical parser we have already developed, and bidirectional tag parser. And these are the research. Last 2-3 years, we have presented like 8 to 10 research paper on different areas. Our fundamental research is based on the basically Tree-Adjoining Grammar that is introduced by Dr. Arvind Joshi in 1975. Then we have eventually enhanced this model and through the different kind of models and parsers. So basically, I would like to introduce the parser. Parser basically a simple back program that analyzes the human language, extract the meaning of the structure of the language, and support various NLP applications. These are the applications like information retrieval, sentimental analysis, machine translation, also speech and QR system like question answering system. And Tree-Adjoining Grammar is basically powerful grammatical formulation for processing large scale grammars. So basically, what are the cause for going to the research for tag? While traditional tag is powerful, but there's some limitation to handling the complexity and nuances of the natural languages. We have analyzed various Indian languages. Also, we have done the English and European languages, and we come up with our research like there's a nuances of the language that parser is not currently able to uh, uh, handle these. So traditional models is basically top down and bottom up approach, left to right. This is the parsing process. So early tag parser faced the insufficiency due to computational complexity and memory uses. Now even we improve the memory and improve the computational infra, then parser are very difficult to capture the statistical and dependency between the structure of the source sentences. So basically this paper present the novel probabilistic parsing framework for Tree-Adjoining Grammar, and that integrate the part of speech information with the lexical item during the parsing. So basically, tag parser predominantly relies on the lexical information, limiting their ability to resolve the structural ambiguity. So basically, earlier parser based on the lexical items, like any sentences, these are different lexical item, but given the part of speech tagging to these lexical item, these information we can use during the parsing process. So basically, these are the already I have told the key challenges of statistical lexical ambiguity, and part of speech tag considerably reduce the ambiguity while limiting the range of the alternative grammatical representation. The one word in English or any other language, one lexical item can represent different meaning in one sentences. So we apply basically POS-Augmented Statistical Parser to facilitate the, we have developed the one translation system that is English to Indian language system, and we applied our research on this system basically. So we also train our corpus on the 15,000 sentences, and we have done the empirical evaluation of the across multiple Indian languages through this approach. This is which we are going to cover in later section of the presentation. So basically this is the basic our workflow, where we come to the raw sentences, we tokenize the sentence, we given the tag post tag annotation of the sentence, and uh, this tag set we have the this basically pipeline. We load the elementary trees for each each post tag, and anchoring the tag set with the pause word, and during the parsing this elementary going to select. We extract the pause feature, we surrounding the pause feature with tag, and these are the we capture the sequence and also keep the feature extraction. Condition of the pause tag is to be actually training system also in the this pipeline. We evaluate the training post sentences, we calculate the probability of the each the post text sentence, and after that on the basically we applied this probability during the selection, during the parsing and derivation, and this is basically reduce the ambiguity and parse the source structure. So in this work we adopt the two-step pipeline where the input sentence are proper process through the external post tag and generate the token level syntactic annotation, and we assign the post tag to each and every word, and also calculate the probability of the, we also assign the probability of the each and every lexical item. So basically, this is a basic architecture on this algorithm. We start the raw sentence, we provide the post-text sentences, we annotate the sentence, we covered the lexical anchoring, the probability, already feature extraction. This is the bigger, basically focus on the post-text sentences and enhance the parsing algorithm. So this is the basically research and environment I would like to introduce, VTAG. This is the virtual tree-adjoining grammar based workbench which we already developed, and through we developed the for each category we have developed the elementary trees, and this is done by our language expert. So basically I would like to introduce basic flow of the translation. This is the input sentence, like design and build the emperor acquire the palace was beautiful. We pre-process the sentence, cleaning the all normalization stage and first level pre-processing. So we basically we covered the design and build the emperor, and palace was beautiful. Now we capture the part of speech through the post tag. We assign the category for each and every item with indexing. You can notice here the by is the prep, and emperor acquire is the noun phrase. All these are we capture this, and after that we covered the tree vector, and we for the each and every token we provide the tree number of trees shortlisted for each token, and after that we cover the we do the parsing, and we have done also generation. This is the pictorial representation of the parsing, how we convert the source sentence into the derivation. So this is the actually how is these each and every lexical item is attached to different lexical item. So this is the basically derivation model, and after that we convert this through the generator. We already developed a generator. In this is we are providing the English to Hindi translation. So this is converted to Hindi here, and any other language we can use the same parser, and we just provide the lexical information and grammar to different target language, and we can translate the in any other language, source to any other language. So basically here we are giving the example of the Hindi. So बादशाह अकबर द्वारा डिजाइन और निर्माण किया गया महल सुंदर था. This is the Hindi sentence. Now basically in depth we do the dot parsing through the how parser work. I would like to show you how parser actually work. So this is the inner picture of the parser. Where the each node have in the 4 dots, and parser traverses the all node. This is the early type of parsing algorithm. So this is basically experimental setup. I would like to tell you how we like generate the tree bank, how we on the all NLP resources, how we develop. The, through the virtual research environment, we have created the all these three. The separate setup and was created to analyze the performance of POS-tagged multilingual tree bank, which we have already experimented or created through our language expert team. Language in different domain, like for Tamil we have different language expert, for the Urdu different language expert. These are the, we have created the resources and empirical evaluation across the multiple uh, which we have done the through the post-tag. The significant gain in parsing algorithm. We analyze the algorithm through the memory, in terms of memory, in terms of execution time. So this is the basically our different multilingual grammar for the statistical parsing. So we have for English to Hindi, we have like uh, 2 to 300 trees. Then for the English to Urdu, we have like 250 trees. For English to Marathi, we have like 300 trees. So the different Indian languages, we have created the tag tree banks. And this is the yeah, basically our experimental setup. We use CentOS and code Xeon processor. Then for the server, we have JBoss, and for the database, we have used MySQL 6.0. And this is the basically summary. We have taken the 15,000 our gold sentences, and out of 15,000, 12,000 sentences were used for the training and taking the probability model. We have created the probability model also, and out of 12,000 sentences, 749 were successfully parsed using the same POS-Augmented TAG Parser. And the parser speed also calculated in space-time, and it's showing like 5 minutes and 30 seconds. It's parse the all 12,000 sentences. So this is the basically experimental summary for how many sentences we parse in English to Hindi, then English to Bodo, then English to Urdu, English to Marathi, English to Bengali. These are the different set of sentences. In some the overall result showing the 30% reduction in parsing time by using the word POS-Augmented Statistical Parsing framework in traditional and legacy parser. That is, we have done, and we have achieved this. And basic conclusion of the this research is basically this paper like discussing the limitation, or start to discussing the conventional tag parser, traditional tag parser. It examining the advances by made by different researcher in NLP field across the globe. We also discuss the limitation and how we can overcome these limitation by using a different approaches. And we have also demonstrated end-to-end pipeline of the post-tag parser using statistical framework, and how we can make the experimental setup, and we have done the achieve the 30% improvement in existing parser. So we believe that POS-Augmented Statistical Parser technique represents significant step forward in this NLP field, offering new insight into the syntactic parsing, paving the way to enhance the language processing capability. And currently, actually, there's an era of AI. So basically, the large language models are generated and created. So we believe these models require the large scale of data. But our research, we can, with limited data set, we can create the tag parser for the any languages, and we can also develop the translation system, and the same parser can be used to any other application like question answering system, syntactic analysis of any source language, any language in the world, natural language, and also semantic analysis. This parser can be used with limited resources and limited person, an expert, we can create the such kind of model. While we believe this LLM used to we required the lots of resources, teams, all NLP, then for creating. So basically, this is useful for creating the different application and practical use also. And future scope, we will identify this. We can enhance the generalization of the. We basically focus the lower source languages where the lower source Indian languages. There's just several Indian languages. These have lower sources that has not imprint on the internet. So we can focus and create the translation system or any other models, or so we can improve the natural resources on the internet by these languages. We can also thinking to integrate our like parser with LLM. So LLM even for work for the with limited data sets also. And domain specific translation, we believe this is useful system and would be very useful for the domain specific, like some agriculture domain for farmers, some services can be developed for the like government policies kind of translation. For this basically this will be very useful, and with the limited resources and with a quick time that can be generated and that can be developed. So these are the basically application we are targeting: question answering system, syntactical analysis, information extraction, and in future also we can provide the real-time parsing for optimize the interactive application, faster processing, and maintain the accuracy. So this will be useful for in future also. We can also NMT models we are also integrate with our tag. So in neural machine translation model can be, when integrated with tag, that will be enhance the potential of the tag and all overall entire system, and that can be further used for any LLM. So these are the reference, and we are really gratitude to the all research happening in the NLP fields, and these are the our encouragement. And in future also we are this kind of platform we would use to present our research and learning and knowledge sharing platform. So thank you the committee and panel for giving us the opportunity.